You to my class today. In our last class, we discussed permutations. Today, we shall be discussing combination aspect of the topic. They're actually together permutations and combinations. But I decided to take the permutation aspect in the last class. So today we are beginning combination. At the end of this class, students will be able to state the meaning of combination, explain the difference between permutation and combination, and use combination in solving problems. Let's proceed to the day's work. Combination. A combination of n objects taken out at a time is selection, which does not take into account arrangement of objects. Now I want you to take note of a particular keyword. In permutation, we talk about arrangements, but combination, we make use of this term, selection and choose. We select and choose. We select and choose. In permutation, remember I told you that order is very important. The order of arrangement of objects is very important. But here in combination, order is not important. That is why you see this last statement here, very, very important. Order is not important. Here, ABC, in combination, ABC is the same thing with ACB, which is also the same thing with A. Okay, yes, the two of them are the same. ABC is the same thing with ACB. Good. BAC is the same thing with BCA, but this in permutation they differ. Good. Now let's quickly take our first example, since we have laid a solid foundation for a combination. Now order is not important for combination, but order is very, very important. Order of arrangement is important for permutation. Example 1, very quickly. Consider the selection of a set of 4 objects. This is the question we are dealing with now. This example 1. 4 different letters from the English alphabet. The letters are the objects. Suppose David selected AERT, Karen selected DENQ, and John selected REAT. Now, the question is this: how many different set of 4 letters can be selected from the alphabet? How many different set of 4 letters can be selected from the alphabet? That's the question. Let's check out the solution in the next slide. The answer to this question, very simple, and we're going to be very fast. I want us to pay rapt attention. If we use permutation first, we will use permutation from the previous section we did. We've talked about permutation. There are P26 and 4 ways of arranging any 4 letters. If we talk about the arrangement of the letters, we're going to have permutation 26 and then 4. Remember I told you we can also write it like this: 26, then we have our 4. Both of them are saying the same thing. Now if we first do the arrangement of that particular one, we want to arrange the total number of 26. We want to arrange 4 at a time. Okay, so remember the formula for permutation is the 26 factorial over 26 minus 4 factorial. We all know what factorial means by now. 26 factorial over 22 factorial. Punch your calculator, you get this answer. Okay, that's for permutation. This question is trying to show us the difference between permutations and combinations. But in this question, the order is not important. So it's going to reduce. Because order is very important, that's why the number of arrangement is as high as this. Now, because we are arranging 4 letters, any set of 4 letters chosen can be arranged in 4 different ways. So we are going to be divided by the 4 letters. So these are the ones that are expected to be the same. Okay, the different order of arrangement, the different order of arrangement that we are going to have in this by selecting 4 letters, by arranging 4 letters. So I'm dividing by 4 factorial, and 4 factorial of course will give me 24. And if I simplify, 4 factorial, remember 4 times 3 times 2 times 1. That gives us 24. So dividing, I have this. Obviously, you see that this answer here is less than what we have here. Because order of arrangement is important, that's why this one is as high as this. And for here, because order of arrangement is not important, that's why we have to divide by that 24 to further reduce it to what we have on the screen. Okay, so that gives us our first example. Okay, we're coming gradually. This first example is teaching us, is reminding us of what permutation is and taking us to combination. So we can see the difference clearly now. So we see the formula of combination easily in our next example now. Now let's check out the next example. Number of combinations. We have this formula for combination. I can write a combination as a function of permutations. I can write it like this: n permutation r over r factorial. Okay, r factorial. Good. And of course, we know what permutation is. Permutation is this n factorial over n minus r factorial. So merging the two together, so I have this formula. So this becomes the valid formula for permutation. But we didn't use this formula in the last example because we are trying to show us the difference between permutations and combinations. Okay, so this has also been stated here for us. So combination is a function of permutation. So take note of this. Combination n combination 0 will give us 1. N combination n will give us 1. Okay, so when you have n combination r, is the same thing. I want you to pay particular attention to this. What this is saying is, if I have 7 combination 2, it will always be the same thing with 7 combination 5. Look at it, this particular D. Okay, and now that n minus r is 7 minus 2 gave us this 5. 7 minus 2 give us this 5. So in the same way, I can have n combination 4 will be the same thing as 9. If I say 9 minus 4, I will have 5. It will always be the same. That's what this formula is just trying to remind us of. Good. Now, so the last example, this is what we will have done if you want to use the formula straight. 26 factorial over 4 factorial 26 minus n, using that formula, the formula up here. Okay, so we will have still gotten our answer that way. Let's quickly go to example 2. Good. Find the number of ways in which 3 components can be selected from a batch of 20 different components. So for this particular question, it means my n is 20 and my r is 3. We want to arrange 20 different things, 3 different things from 20 objects. Okay, number of ways in which 3 components can be selected from a batch of 20 different components. So we'll quickly write it as, take note of the terms they are using here. In combination, the terms peculiar to combination is select, selection, and what? And choose. So most times this should, when they use this term, it should quickly signal you that they are talking about combination. Okay, so in permutation, they will say permutes or permutation or arrangement, number of arrangements. So let's quickly simplify this now using the formula. Very simple. We all know the formula now. Combination is what? N factorial over n minus r factorial. Then we have r factorial. Good. So that's 20. N is 20. The r factorial is this 3 factorial, 20 minus 3. Simplify that. Of course, we are going to have that answer. Okay, we have done this particular one in our last class under permutation. We've learned how to simplify factorial. So if you simplify that factorial, that is what I have. So that takes us brings us to the end of example 2. Now let's quickly go to the next one. In how many ways can a group of 4 boys be selected from 10 if the eldest boy is included in each group? How many ways can a group of 4 boys be selected from 10 if the eldest boy is included in each group? Now look at this term now. We're talking about selection. Good. So let's see the solution. The question A. We want to choose 3 from 9. But the question actually says there are 10 boys. We want to select 4 from them. But this one, they have given us a condition. Eldest boy is included in the group. If an eldest boy is included in the group, that is why we want to choose 3 from 9. That means out of those 4 boys, since an eldest boy 1 is very sure to be part of it, then what is remaining? Is remaining 3 for us to choose from. If I remove the eldest boy from that 10, then I have my n will now be 9. Okay, my r will now be 3 for that question. So that's how we have 9 combination 3. Okay, because they've given us a condition that the eldest boy, since the eldest boy is fixed, is sure he will be there, so it will not be part of the 4. So we only talk about selecting the remaining 3. So if I simplify that, I'll have 9 factorial over 3 factorial. 9 minus 3 will give us 6. Simplify, you have your answer. That should be very simple for anybody to do. If the eldest boy is excluded, it is actually choosing 4 boys from 9. We now want to choose 4 boys from 9. Okay, from 9. If the eldest boy is excluded now, that means you still want to choose 4, but the eldest boy will not be there. So that means the number of n here we still have reduced to what? To 9, because the eldest boy will not be here. Okay, so I have n combination 4, but this will still be 4. We are still selecting 4 since the eldest boy is not part of the selection. So we want to select 4 out of 9 now. For the last one, we selected 3 out of 9 because 1 eldest boy is sure to be there. But for this case, we are only selecting 4 out of 9. So looking at that, 9 factorial over 4 factorial, 9 minus 4. Simplifying that, you have 126. Now the C part, the number of all possible groups is 10 combination 4. Now the last question is asking us about the percentage. The last question is asking us about percentage. What proportion of all possible groups contain the eldest boy? The proportion of all possible groups that contain the eldest boy. So the first thing we need to do is to get the total number of all possible selection we can have, 10 combination 4. So simplify, we have this. So the number of boy that involve the boy is 84. So we have the proportion will now be 84 over the total, 210. So that gives us, simplify, 40%. That gives us 40%. 2 over 5 times 100 will give us 40%. That's the proportion the question is talking about. Good. I believe we've done justice to this question. Please do not forget to always post your question under the comment and question section, the notes and comment section. Good. Now let's look at example 4 now very quickly. A class consists of 15 boys, of whom 5 are prefects. How many committees of 8 can be formed if each consists of exactly 2 prefects and at least 2 prefects? Okay. How many committees of 8 can be formed if each consists of exactly 2 prefects? Let's see how we translate that here. The number of ways of choosing 2 prefects is or from 5. We have 5 prefects, so that will be 5 combination 2. 5 combination 2, that gives us that. Okay. The number of ways of choosing 6 non-prefects from the 10. Okay. Now if you look at the question, we have 5 prefects, then the remaining will be 10 non-prefects. Good. So we have prefects, there are 5 prefects, that's what the question talked about. Then we have 10 non-prefects. Okay, so for choosing, the number of ways of choosing 2 prefects to be 5 combination 2, because there are 5. The total for that is 5. That's why we have 5 combination 2. The number of ways of choosing 6 non-prefects. Since you remember this question says we should choose 8. Since we have chosen 2 prefects, the remaining to be chosen from the other 10 is what? 6. So that's why we have 10 combination 6. So if I simplify that, I have 210. Okay, so the number of possible committees with exactly 2 prefects, you see, this is 2 prefects, the 2 prefects, the remaining one is 6. So if we multiply the results 10 times this, I have 2,100. Then the second B part of the question, number of committees with 3 prefects. Now that we have 3 prefects, then we can only choose 5 from here. We can choose 5 from non-prefect. We can choose 3 according to that B. Remember, we have to choose 8. So we have 5 combination 3 times 10 combination 5. So the 3 plus 8 still gives, 3 plus 5 still gives us the 8. So simplifying each of that, 5 factorial over 3 factorial times 2 factorial. Then simplifying this combination, I have this. So multiplying the two results gives me 2,250. Now number of committees with 4 prefects. Now if I want to choose 4 prefects, then I can choose 4 from here according to C. Then I can choose also 4 from here. That's for this part now. So 5 combination 4. Since there are, we want to choose 4 prefects from 5. We also want to choose 4 non-prefects from 10. Simplifying that, I have this. So all the number of committees with 5 prefects will now be what? We have to add all of them together. Number of committees with 5 prefects. Okay. So, okay, let's finish it. We've not finished the set. 5 prefects. If I have 5 prefects, then I can also have 3 non-prefects, because the question says at least. Okay, simplifying that, I have 120. So the final answer will make us to add all of them together. Add everything together, we have 2,100. Okay, since he's talking about at least 2, that means we could have 3 prefects, we could have 4 prefects, we could have 5 prefects. Good. So simplifying all of that, this becomes my final answer. Good. Let's see. I hope this is clear. In case you have any challenge, please post your question, your comments. Last one. Out of 5 mathematicians and 7 engineers, a committee consisting of 2 mathematicians and 3 engineers is to be formed. Okay? Out of 5 mathematicians, 7 engineers, a committee consisting of 2 mathematicians and 3 engineers is to be formed. In how many ways can this be done? If the first condition, any mathematics and any engineer can be included. No restriction. So that gives us total of five engineers. That's why we have 5 combination, and we have to select 2 according to the question. This is the 2. We have to select 2 from the mathematician. That's why we have 5 combination 2. Then the other one, we have 7 engineers, and we have to select 3 of the engineers. So we have 7 combination 2. Simplifying that, of course, we all can do combination now. So the answer gives us this one. Okay, 5 combination 2 is 5 factorial over 2 factorial times 3 factorial. Then the other one simplifies to be this. Okay, so multiplying the two answers gives us 350. Now looking at the second part of the question, the B part, one particular engineer must be in the committee. If one engineer must be in the committee, it means out of the 3 engineers now, I only have 2 left to choose. We're supposed to choose or select 3 engineers. They say one particular one must be there. It means I only have 2 to choose from. Since one is so sure to be part of it, so the only thing we are going to do here is one particular engineer. For the mathematician first, that's still 5 combination 2. 5 combination 2. That's why we have this one. Then since one is a particular engineer will be there, so we only have 2 left to be choosing. That's why we have that 2 at the bottom of the combination here. Good. We can't choose 3 again because a particular one must be part of the committee. So we are removing that one as part of what we are selecting now. So 2 plus 2 at the bottom of question B of the combination, 2 plus 2 here. The 2 plus 2 we have there will give us 4 plus the engineer that must be there. So if I simplify each of the combination in circle, that gives us 5 factorial 2 over 2 factorial times 3 times 6 factorial over 2 factorial times 4 factorial. Simplifying that, of course, calculator will give you the final answer. Just press your calculator. I have this. Then my final part of the question, 2 particular mathematicians must not be in the committee. If 2 particular mathematicians must not be in the committee, so that will affect the total. We still want to select 2 mathematicians, okay? But since 2 particular ones must not be there, we remove 2 from this 5. So it will reduce to 3. So that's why we have 3 combination 2 now. Since 2 must not be there, the 5 at the top will reduce to 3. Then for the second one, they didn't give us any condition about the engineer. So we still have 7 combination 3 as we have here. So simplifying what we have, we give us 3 factorial over 2 factorial times 1 times 7 factorial over 3 factorial times 4. So simplifying that, I have this. So with this, we've done justice to combination. Okay, so in this class today, our summary is we have learned that combination has nothing to do with arrangement of objects or whatever they are talking about. No order is required in combination. We only choose and select irrespective of the order of arrangement for combination. We also learned how to write select a number from a total given. So that's where we have n combination r. Then the formula for simplification, this. Remember I said combination is a function of what? Permutation. That's why you have that permutation there. This brings us to the end of our class today. Make sure you attempt the quiz. The next step that follows this particular content page we just finished treating, attempt the quiz and attempt the assignments on the pages. Check the pages of the portal. You will see the assignment there and drop your comments and answers there for me. Thank you. Have a nice day till we meet in our next class. In our next class, we are going to be starting logical reasoning. Thank you. See you next class.